Welcome to part 2 of the Chapter 7 demo. We left off last time by creating the outline of a house that we traced over a CAD file. So that's an important skill to have. We don't always do our architectural projects that way, but certainly a good number of them are conducted in that way. And so knowing how to both link or insert a CAD file and then how to use it sort of as the outline of our floor plan is an important skill. We finished up last time by creating the foundation underneath this house, and then we added a footing to that foundation using some structural tools. You will notice, however, that the floor system was not placed. That's not part of the lesson this week. We are going to be dealing with floors and the creation of floors in another lesson in coming weeks. So for now, we're just going to have to deal with the fact that we can see right down through our house or up through our house, depending on the direction you're looking at it from. We're going to continue our exploration of creating walls this week, and we're going to be digging into maybe some less used skills, but certainly important ones that you'll need to have going forward. And we're going to be starting off talking about the differences between the various wall types that we have available to us. Now, to be clear, they are all system families. A wall is a wall is a wall all the way through Revit. Revit always is going to recognize it as a wall, but you've probably noticed that there are some basic categories that you'll see when you select a wall and you go into the drop down for the type selector. The ones we're going to use most often are going to be the basic wall type, but you will notice that down at the bottom you have something called a curtain wall, and you also have something called a stacked wall. There's nothing too mysterious about these wall types, but I do want to take just a moment to explain what they are. We'll start with a curtain wall. A curtain wall is sort of a hybrid between a window and a wall. And we've all experienced curtain walls before. We've seen them in places like storefronts. If you go down to Rushmore Crossing, for example, that outdoor mall we have in Rapid City here, you'll notice that most of the storefronts are large walls with windows in them. And the walls are sort of structurally held together by aluminum frames, right? So we have these aluminum frames that are all sort of tied together, and then panes or panels of glass are set between those frames. And that is essentially what a curtain wall is. And you can sort of tell that by the icon that Revit uses to sort of show the curtain wall. And although we're not going to cover curtain walls and their creation in this class, you can expect curtain walls to be covered in future classes. Typically, those are going to be introduced in the third semester. So a curtain wall can exist on its own. It can sort of be hung or attached to the exterior part of a building, and it does serve the purpose of a wall. It separates the interior from the exterior spaces. But curtain walls can also be embedded into existing walls of other types, just like a window or a door would be. Curtain walls are very versatile as well, because not only can you customize their height and their length, but you can also customize the grid system that those metal frames are sort of created along. And so a curtain wall does come with a grid system, which is separate from what the dividing pieces, which we call mullions. And you can see, if you feel like experimenting with curtain walls, you certainly could do that. You can see up here in the ribbon on the architecture tab that we do have a curtain grid and a mullion. These are two separate objects, but both of these sort of come together to form the curtain wall. The grid system, you could sort of think of that as the framework for the mullions. The mullions are going to align with and attach to the curtain grids. So I think that's enough information about curtain walls for now. The last type of wall that we see listed in that type selector down at the very bottom is a stacked wall. And to describe a stacked wall, we're just going to take a look at this one right here. So we're going to go ahead and select this stacked wall, and then we're going to click Edit Type. And what's going to end up happening probably is it's going to change this wall that I had selected to a stacked wall, but we're going to change it back just by undoing it when we're done. So I'm going to go ahead and click on Edit Type just so I can get in and show you what this looks like. So the type properties open up, and we've only got one entry in the type properties. It's called Structure. When we click Edit on that, the only thing you see here are wall types. Okay, so a stacked wall, to create one, depends on you having already created one or more wall types in the basic wall segment, right? So what we have here are two basic walls that are stacked on top of one another. So obviously you have to have that wall type created already before you can define a stacked wall. And a lot of times we'll create a stacked wall when you have two separate things going on the exterior of a building. For example, we see oftentimes the lower portion of the wall looks like masonry, and it might be thicker than the rest of the wall, and then up above that point, which may be at the 3 or 4 foot level, you'll have a different wall type kind of going up from there. So it's necessary to not only have a place where we can list the wall types that are in this stacked wall assembly, but also where one sort of starts and stops and leaves off, and where the other one takes off from there. So in this situation, you can see that the exterior brick on wood stud is set at a height of 7 feet, and from there the next one is going to sort of take off and go up from there to a undefined height. So they call that variable. And so we'll see this in action. We'll just go back into the model. We'll spin around here and take a look, and you can see that, yeah, this wall type is brick all the way up to the 7 foot level, and then it sort of takes off with another material from there. So I am going to go ahead and change that back since we're done talking about it now, but I just wanted to give a quick introduction of what those other two wall types are meant for. We have two other sort of unconventional, maybe less frequently used options when we create walls. One of them is creating a wall that is actually sloped or slanted a little bit, and we see that occasionally in situations where the wall is either intended to mimic sort of classical masonry construction, where the lower part of the wall used larger blocks or larger stones, and they got progressively smaller close to the top. And so when we see a tapered wall like that, typically it's not built in the classical method, but it is on the outside at least intended to look like that it was. And we see that a lot in architecture. We use modern construction techniques, but we sort of design them in a way that mimics classical construction techniques. So let's take a look at some wall sections from an actual project that was done several years ago in Rapid City, and you can see that there's sort of that taper going on this wall section right here. You can tell that it's not classical design. You can see that there's a modern design behind the facade out here, which is real masonry, but it's slanted just by sort of tapering or slanting the structure behind the wall, not by increasingly larger stones or blocks as you get closer to the bottom. So that presents a problem in Revit that they have solved, which is to actually be able to slope the wall itself. So let's get back to doing some drawing. Let's go to the first floor plan view, and just off to the right of the existing building here that we created in part 1, I'd like for everybody to just create a wall from north to south, just kind of somewhere in this area right here. So we'll go ahead and go to the wall tool. And we're not going to concern ourselves with the options on this one. Any old group of settings is going to work just fine for this, I think, as long as the wall has a reasonable amount of height to it. And it actually doesn't in this case, so I am going to change the constraints of this thing. The top constraint I'm going to set to the roof, just to make sure that the wall height is at least 8 feet. So I got 9 foot 1.5 showing here. And then I'm going to change the wall type to just something generic. We're going to keep this fairly simple. So I'll say generic 8-inch, and I'll just create the wall right along here. And I'm not sure why I'm not being able to see that right now. We'll go ahead and just place it though. And we'll let that error dismiss. And then let's switch back to a 3D view and see what we actually got. So I may have needed to take a little more time in choosing my settings. But okay, so I did start this wall sort of at the top of the wall level. And so I'm going to change that. I'm going to say Base constraint, we're going to set that back to top of foundation. And then for the top constraint, we'll go ahead and set that to roof. Okay, so that's enough of a wall to where we can see what's happening here. And I'll select that wall, and what I'm going to be looking for is a particular setting in the properties of that wall. So make sure you don't have anything else selected. You can verify that by just clicking on the Modify tool a couple times, and then just single click on that wall we just created. And over here in the properties, under the category of cross-section definition, we're going to change that cross-section type from vertical to slanted. And it didn't do anything visibly other than give us the ability to change the angle. And so you see that the angle from vertical is listed here as 0 right now. So any number that we put in, it's going to either lean it left or right, depending on if we put in a positive or a negative number. So let's go ahead and type this as 10. We'll just put it a 10-degree slant to start with to see what it does. And you can see that that's going to tip it to the left. Okay, the height did not change. Okay, so that wall actually became longer so that it could reach that same height. But the angle did change, obviously. And so if our intent was to angle it the other way, we certainly could go back and do that simply by putting a negative sign in front of the angle number. And then we'll just flip it the other way. Okay. The other type of wall is that you saw listed there when you pop this down is tapered. So we can just go ahead and demonstrate that too. Say close. It didn't like the wall type, so I'm going to go ahead and change that as well to something else. And it's possible that it didn't like it because of the composition of the wall. But let's go ahead and read that whole error message again. So we'll go ahead and change this back to tapered. And it says, oh, set a layer in the wall type to have variable thickness. So we're actually going to have to change some of to do a tapered wall, you're going to have a wall type that's compatible, which means you're going to have to change the properties in here. So you can see that the thickness is set to 8 inches, and that's a fixed number unless we click this box right here that says variable. So we'll go ahead and say OK to that, and then we can go ahead and set this to tapered. Now the tapered is going to require 2 angles, right? So we have to check this box to enable those, and then we can set the exterior and the interior angle separately. So I'm going to set this to 5 for both. And you can see what the result of that is. So again, we're mimicking classical construction techniques where the base part of a masonry wall would be thicker than the top. But we're doing it in a way that it allows us to use modern construction methods. So for the model here, we're just going to leave that tapered wall in place. That'll be part of the screenshot that you'll save for this lesson. And now we're going to move on to the last part of our discussion over Chapter 7, and that is we're going to talk about rooms. And rooms are fairly basic, so they don't really justify having an entire chapter to themselves. They just lumped rooms in with walls because there is quite a close relationship between the two. They're distinctly separate things, but rooms rely on walls to define their boundaries. So let's just get into it. We'll go to the first floor plan for this. And I think for this part, we're going to hide the CAD file that we're seeing there. We're kind of done with that now, so we can use sort of a permanent method to hide this thing. If we right click on it and we say hide in view elements, it takes it out of this view. Now that floor plan, that CAD file is still going to be visible in other views, remember. It doesn't go away. I've only hidden it in the first floor view. If my intent was to ultimately keep that in the view, I would have used temporary hide isolate, which as you remember is the sunglasses down at the bottom. So when we use room elements, I'm going to talk just a minute about what room elements are. I'm defining the spaces, and I'm also going to be giving each of the individual spaces a label. We see that a lot on floor plans, where this area right here, even though it might be fairly obvious to us, is a bedroom. But we're going to still label that thing. In fact, we might call this one master bedroom. And then this one down here might be bedroom number 2. And then we might have some additional bedrooms on another level that we would continue to add numbers to define them specifically. And the reason we want to do that is a lot of times we are going to define within the plan set how those rooms are going to be finished. So room number 1 might have a different floor finish, might be carpet, and another room might be hardwood or laminate or something like that. So we need to be able to differentiate between the different spaces throughout our building. We are even going to create a room in the garage. So the spaces don't have to be necessarily living spaces. They can also be utility spaces. Now, I wouldn't go as far as to create a room inside of a closet necessarily, although you could, and the larger the closet, the more likely you would probably want to do that. So what we're going to do in this case is we're going to create a room inside the bedroom, but we're going to include the closet space in that room. Same thing that we're going to do sort of in the maybe the kitchen area. We could include the pantry in that space if we want to. So the entry closet could be grouped with the living room, for example, so that we get all of the square footage of the space. We're not leaving anything out necessarily, but we're not having to create a whole separate room for that one little tiny area. So that's one thing that we do with rooms in Revit, is it gives us the ability to define the spaces and label them. The other thing that it's good for is when we go to create a table or what we call a schedule. Most of you are probably already aware what a schedule is and what it's used for. We've talked about schedules as they relate to windows and doors in the past, and it's a nice, easy way to sort of offload the amount of information that you have in a floor plan to another sheet someplace else. And you can put a lot of detailed information in a schedule that talks about the specifics of each individual door or each window type that you have in your plan. The same thing can be done, and often is done, especially in commercial construction, with rooms. Rooms have a lot of information that is needed to be stored in them, and just a few examples are, we already talked about, how the floor is going to be finished, what finished material is going to go on that floor. But we can also store, what color should the paint be, or what should the finish type be for the walls in that room. If you look at the bottom of a wall in your house or in most buildings, you'll notice that there is a baseboard at the bottom, right? The baseboard is sort of that trim piece that goes along the bottom of a wall. We might also have something similar at the top of the wall. We call that crown molding. The ceiling type is another finished material, right? We need to be able to define what the ceiling is going to be in an individual space. And that's especially true when we get into commercial design, because sometimes in a commercial building, a ceiling is going to be those drop-in tiles that sit on a grid. Other times it's going to be a hard surface like you would see typically in a house. So just to give everybody an idea of what it is we're talking about, this is what we call an interior finish schedule. This is also from an actual project someplace, right? But you can see all of the individual room numbers listed here in the far left column. These are kind of broken out by the various suites within this building, okay? But each one of these rooms is going to have a specific thing defining how they're going to finish the floor, the base, the walls. If there's a wainscot, that's that sort of paneling you sometimes see at the base at the bottom of a wall, and then the ceiling. And so each one of these things might be further defined by which wall is it, north, south, east, or west, on and on and on. So lots and lots of information we can put into a schedule. But in Revit, if you don't have the rooms brought in to the individual spaces, there would be no place to store that information. Right now, there's really no way that we can plug into the database, and that's essentially what Revit is. It's a database of a building, right? But there's no place to store that information yet. So we have to put rooms into the spaces to store that information so that we can put it into a schedule ultimately. All right, so with all of that preamble out of the way, let's go ahead and create a room. And you can see right here on the Architecture tab, under the Room and Area panel, we have right here a room. Now, we don't have to concern ourselves with this thing right now, recenter reference. We're just going to say room, and then we're going to hover our cursor into one of the enclosed spaces. I say enclosed because this room is defined by 4 walls that are essentially enclosing the space. Now, the door also is one of the boundaries of that space, both to the closet and to the hallway here. So we're just going to go ahead and place that room right here. And you can see right away it gives it a number, and it even gives us a little readout of how big that room is. Okay, so let's go ahead on this one, because we have a large walk-in closet here. We'll go ahead and create a separate room in there, and then we'll do the same thing with the bathroom. Let's go down here. Let's go ahead and create a room in the other bathroom, the other bedroom, and we can come back and edit this later. And then why not? We'll just go ahead and create one for the pantry as well. Now, what we run into out here, oh, let's get the garage too, since that's kind of a finished space. All right, so what we run into out here is we have basically 3 rooms all in one. We'd have what you would sort of think of as a kitchen, a dining room, and a living room space. Okay, so for now, oh, and you'd also kind of maybe want to separate out this hallway too as a separate space. So we'll go ahead and just place one room that encompasses all of those interconnected spaces, and then we'll come back and we'll divide out those spaces into individual spaces, which does present a little bit of a problem for us because we don't want physical walls between those spaces. We want to be able to define them in some other way that is sort of transparent. And that's essentially what this room separator tool is for. We can just simply draw lines across open spaces to create a boundary that Revit recognizes as a room separator to divide those room objects we're putting in here into separate pieces. So I mentioned room objects. It's important that we understand that these are actually objects in our model, and if you hover around somewhere near the label that it put in, you'll notice that it'll highlight and you can actually select it. So that object right here that we have selected is a room object. And it's not, other than the room label, it's not intended to be printed. It doesn't really take up any kind of physical space in your model, but it does give you the ability to store information about those individual spaces. So you can see all of these individual instance properties, these parameters that we can populate with information about the occupancy of that room, the department it might belong to, for example, the base finish, the ceiling finish, all those things we talked about that can then be extracted and pulled into a schedule. All right, so I'm going to temporarily show where those room divisions are by just clicking on this light bulb button to display those hidden objects that I put in earlier. And then we get to define exactly where we want those room separation lines to be. So I'm going to draw my first room separator kind of right across from this point right here on this wall, straight across over to this wall, and that's going to divide up the dining room from the kitchen. Now you can put that line anywhere that you want, but I just thought that kind of made sense. But if you wanted to run it down a little bit lower, run it up a little bit higher, that would be totally up to the discretion of the person doing the modeling. And then we also need to separate out the dining room from the living room. So let's do one more separator line. And we're just going to go from the corner of this all the way over to right here. So now we've separated that space out too. Now, if it would have been part of this discussion and we would have put these stairs in here, we might have separated the stairway out into its own room so that we could label it as stairway, right? But that's not part of what we're doing this for this particular lesson, so we're going to leave it as is. One more separator line we're going to need, and we'll just go ahead and use that sort of that same division line to separate the hallway from the living room. So now that we've got all those spaces divided, I'm going to go ahead and re-hide those elements, and then I'm going to pull this room label sort of up into the space that it's representing. And you can see if I select it now, it is just this area. So I actually have more rooms to create now, don't I? So go ahead and click on the room tool again. We're going to come down here and we're going to create one for the hallway, one for the living room, and one for the kitchen. So because rooms can also be used to define the square footage you have within your building, it's a good idea to make sure that all of the spaces are accounted for and used. So the best way to sort of preview what is and what isn't a room currently is to just click on the room tool, and it gives you a preview of all your existing rooms. We have a few spaces that are usable, that are not defined: the closet for the bedroom, the closet for the hallway, and the closet for the living room. So we learned how to create boundaries that are not walls, but how do we turn a wall into a not boundary, right? And that's basically what we want to try to do, is tell Revit that we don't want this wall right here to act as a separator between these two spaces. We want to include the volume of the closet in with this room right here. And it's fairly simple to do. All we have to do is select the walls, like so. Pick both of these walls, just Control Select, and then come over here into the properties of those two walls, and you can see this property right here is called Room Bounding. It's checked right now. So all we have to do is uncheck that, and those two walls are now no longer recognized by Revit as a boundary to the room. And so now when we select the room, we can see that it fills the entire closet space as well. Let's go ahead and do that to the closet in the hallway and the closet in the living room as well. And I think that created a problem for me because I didn't run this all the way down. So I probably should not have included this wall in that group. I'm going to go ahead and just take that one out. We'll go ahead and recreate the room bounding properties of that wall, and then we should be good. So we'll check the boundary of this. Looks good. Check the boundary of this, and that looks good as well. So the last skill that we're going to explore here is the room tags. We're going to talk a little bit about how those work rather. And you probably already noticed that the numbering was sequential. So these things started at room number 1 and they went to 2 and 3 and just kind of followed the order that I clicked and created those rooms in. But you can certainly change those numbers as you would expect. You just can't have two that are exactly the same. So if you want to rename the rooms to something else and you want to change their numbers, just make sure that you're using unique numbers. Now the room name can be the same. You can have, for example, multiple rooms called office or bedroom. But the numbers themselves, that's what Revit is going to use to sort of uniquely identify a specific room. So that you could kind of think of as a instance property. This one up here you can kind of think of more as a type property. To edit the room name, you just simply slow click on it twice, and then you can type in whatever you want. Or you could say master bedroom, for example. And the number, you might want it to be 001 to make room for additional changes. This one right here we might rename WIC for walk-in closet. so forth and so on. Now we don't always want to see a room number, and we don't always want to see the square footage under that room number or name. And so it's important to realize that this tag that was created here was done using a specific type of tag. You can see this room tag is called room tag with area. There's also just room tag, and then there's room tag with volume. Let's go ahead and change it to room tag, see what happens. So we still have a number listed in there. Let's go ahead and dig into this a little bit and see what the type properties are for this particular tag. You can see one of the boxes that's checked in here is called show room number. Okay, so if we didn't want to see that, we could just simply uncheck that. We'd probably want to create another type. We would duplicate and create another type before we did that for real. But now we can see that that cleaned it up, and this is typically more what you would see in a residential project. This is a perfect opportunity to show you this other tool that's not really part of this chapter, but match type properties. We're going to go ahead and click on that. We're going to select this as our sort of source, and then we can go around and we can click all the other tags, and they're going to update to that same type. Let's go ahead and rename all the rest of the rooms to something more appropriate, and we're going to call it good at that. There we go. We've got it all updated, and except for this one, right? So you just put hall there, for example. And then the last thing we would probably do, because these room separator lines do print, we don't want them to be on our document. We don't want to see a line across there. So typically we would hide these. So I'm just going to say right click, hide in view by category, and then all of them are going to go away. We can always bring them back by clicking on the light bulb, and that's going to display them temporarily, show me all the hidden items in there. But for the most part, we would not want to see those in the document. Okay, so that concludes our lesson part 2 for chapter 7. Reach out if you have any questions on that, and we'll see you all next time in class.